Okay everybody, so today we're going to combine our knowledge of exponential functions with our knowledge of transformations, and we're going to actually transform exponential functions. Okay, so the one big thing you have to remember is that it's a little bit different because the parent function of an exponential function changes. With everything else, there's a constant same parent function. So for instance, if you're transforming x squared, it's always x squared that you're transforming. If you're transforming a reciprocal, it's always 1 over x that you're transforming. However, with an exponential function, it depends on the base. So you might be transforming 2 to the x and then doing stuff with it. You might be starting with 3 to the x, then moving it. You might be starting with 1 over 4 to the power x and then moving that around. So pay careful attention to that, because that is a big difference with exponential functions as compared to any other kind of function. So these are the steps you need to go through. So this is basically just a list of how you do it. So first you factor out k to properly identify the d value. Okay, then you write out the description of each transformation and the order you will apply it. Okay, I'll be honest, unless I ask for this on a test, and I might ask for it, this isn't 100% necessary if you are really, really good at transformations. Okay, I like to do it because even if you, instead of a vertical stretch, you just write VS for vertical stretch, I just like to really visualize what's going on so I don't make any mistakes, and so the numbers have some meaning to me. And remember to apply it in this order: RST, reflections, stretches and compressions, and then translations. That's because of bed mass. Anything that's multiplied has to be done before anything that's added or subtracted. Then you identify the parent function. So that is different in an exponential function as compared to a non-exponential function. And then you create the transform function either on the graph or on the table of values, and then you graph it. So you have two options. We'll go through the graphing option first, okay? So if you're going to do it as a graph, first of all, you apply any reflections, so either up and down or left and right. Then you apply any vertical stretches or compressions, then any horizontal stretches or compressions. You apply both the vertical and the horizontal translations at the same time, and then you draw and label the horizontal asymptote. Okay, its equation is always y equals c. Because originally the horizontal asymptote is y equals 0, and now you're just moving it up or down by a vertical translation, which is always given by c. So that's nice, that's an easy way that you can come up with the horizontal asymptote. Okay, so basically you just take the point where it is, the point that you know is on the original, and you just do all these things to it. Reflect it if need be, then stretch it up, stretch it out, or compress it in. Okay, and then just move it left or right, and then up or down. And then you have your new point. Okay, so that's one way to do it. Another way is to just use the table of values. Okay, I'll be honest, this way I find it a lot easier. The first way is more visual, this way is more numerical. So it just depends what kind of learner you are. I prefer this way personally, but if you like the graphing way, that's fine too. So you identify the A, K, D, and C values. Then from the table of values of the parent function, so you need to have your table of values from your parent function, then you do this to each of the points. So all of the X values you divide by K, and then you add D. And then all your Y values you multiply by A, and then add C. Just be careful that your D value you're identifying properly, okay? Because normally, remember, it's of the form Kx minus D. So if you have like 3 bracket x minus 3 here, your D value is 3, not negative 3. But if you have 3x plus 2, here your D value would be negative 2. So just make sure that you're identifying the D value appropriately. And then once you have those points, you just plot those coordinates, and there you go. So again, I find that simpler. Okay, then you can verify your points by plugging in the X values you found, and then put them into the transform function and make sure you get out the same Y value. Either that's from your graph that you created or from your table of values. And then you can hand in your test being confident that you did it right. So let's do some examples. Here's 2 examples we're going to work through. So you need to get out some graph paper, and you might as well just make these graphs like a full page or at least half a page. Don't try to like cram it into one little section. So I just wanted to identify the parent functions of each of these first, so you know what I mean. So this here is the parent function 3 to the x. So 3 to the x, okay? So be very deliberate about knowing that, because you don't want to think that there's a vertical stretch by 3, for instance. The vertical stretch is going to be by 4, and then a reflection. But 3 to the x is the parent function. Okay, in this case, the parent function is 1/2 to the power x. Okay, the k value is -1/4, the a value is 3, the d value is -1, and the c value is -1. Okay, so but the parent function is 1/2 to the power x. Okay, so that's going to be a difference, is identifying the parent function. Okay, so let's do the first one so you can see how I set it up. Okay, so think about perhaps why I set it up this way, that I have way more room down here, okay? Because I'm looking at the equation and I'm seeing that there is going to be a vertical reflection. So my equation that I'm transforming here is g at x equals -4, 3 to the 2, and then I'm going to factor out k, x minus 2, plus 1. Okay, so this one I'm going to do by using the graphing technique, and the second one I'm going to do using the table of values technique, so you can see each one. So I take a look at this and I think, what is going on here? So I'm going to have vertical reflection, a vertical stretch by 4, okay, a horizontal compression by 1/2, okay, that's what that 2 means. And then I'm going to be going right to up 1. Okay, if you don't know where I'm getting those parameters from, you need to go back and watch the video on transformations, the one called Transformations, putting it all together, and that will say where all these parameters are coming from, okay? So, I just take the points. So I'm going to start with -1/3, okay? So notice I plotted my graph of 3 to the x. So I always have 0, 1, but then 1, when I put it in, 3 to the 1 is 3. And then 3 to the power 2 is 9, okay, and then -1/3. All right, so I'm actually going to transform 0, 1 first. So 0, 1 gets reflected down to -1, stretched by 4, so that's -4. Okay, compressed by 1/2, that doesn't change. And then I go right to up 1. So be careful when you're graphing, because going up 1 in this case, notice my scale is, it's 3 for every tick, so that would be up to -3. So be careful not to go up a whole unit if your scale is different. Okay, so then the point 1, 3. It gets reflected down here. Okay, it's vertically stretched by 4. So that's down to -12. Okay, then it gets horizontally compressed by 1/2, so that's 1/2 in. And then I go right to up 1. Let's go there. Okay, then 2, 9 gets, again, reflected down here to 9. Then multiplied by 4, so 4 times 9, so 1, 2, 3, 4. So I'm way down here. Then compressed, oops, I'm way down here. Then compressed by a half, so it's 2 out, now it's a half of the way to 1, and then I go right 2, up 1. Okay? Now, negative 1/3, it gets reflected down. Okay? Vertically stretched by 4, so that's 4/3, so that's just kind of to 1 1/3, not that much difference. Orally compressed by a half, so in. Okay? Right 2, and up 1. Okay, and then we get our horizontal asymptote of y equals 1. So it's basically going to look like this. Okay? And then you can label your coordinates. Okay, so this would be, for instance, 2, comma, negative 3. So let's make sure that's right. So you put in 2 here. 2 minus 2 is 0. So 3 to the 0 is 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So I know I got that point right. Okay, this point here is 2.5, comma, I believe that's negative 11. Okay, so 2.5 minus 2 is a half. 2 times a half is 1. 3 to the 1 is 3. Negative 4 times 3 is negative 12. Negative 12 plus 1 is negative 11. I did that right. Okay, so you can do that for all of your points. And there you go. Okay, for the next example, I'm going to put this closer so I can fit it all on here. There we go. Okay, so again, I said I was going to do this with table of values. So notice I started with 1/2 to the x. So it starts looking in this direction because 1/2 to the power x shows decay, like this. So my initial table of values, that's x and y. So I'll go negative 2, negative 1, 0, 1, 2, 3. So 1/2 to the negative 2 is 4, okay? 1/2 to the negative 1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is a half, and then a quarter, and then an eighth, okay? So I'm actually going to extend this up a bit further to negative 3. That would be positive 8. There we go. So my a value on this example is 3. My k value is negative a quarter. My d value is 4, positive 4 once you factor out k. Okay, and my c value is negative 1. Okay, so I'm looking for g at x equals 3, bracket 1/2 to the power negative a quarter, bracket x minus 4, right? Because the negative a quarter times 4 would give you back 2, or times negative 4 would give you back plus 1. That's how I know I did it right, minus 1. Okay, so all of my new x values, okay, all the new x values are going to be divided by negative a quarter, which means the same thing as being multiplied by negative 4, okay? So divided by negative a quarter is the same thing as multiplied by negative 4, and then you add 4 because they're going right to 4. Okay, all the y values are being multiplied by 3, and then going down 1. So now I just simply calculate that. So negative 3 times negative 4 is 12. 12 plus 4 is 16. Negative 2 times negative 4 is 8. 8 plus 4 is 12. Negative 4 times negative 1 is 4. 4 plus 4 is 8. Then we get 4. Okay, 1 times negative 4 is negative 4 plus that's 0. So negative 8 plus 4 is negative 4. And then 3, that's negative 12, so we get negative 8. Okay, those are my new x values. Now my y value is being multiplied by 3, and then I subtract 1. So I get 23, 11, 2 times 3 is 6, minus 1 is 5, is 2. So 1.5 minus 1, so that's a half again. I do get a half again. So 3/4 minus 1 is minus a quarter. And then an eighth times 3 is 3/8. 3/8, so that's minus 5/8. Okay, my horizontal asymptote is going to be at y equals minus 1. So I'm actually going to draw that first. Okay. And then I just plot the points, okay? So 16, 23 won't fit. 12, 1, 2, 3, 4, 5, 6, 7, 8, 12, 11 won't quite fit. But so if you can fit 12, 11, then do it. 8, 5, 1, 2, 3, 4, 5, 6, 7, 8, 1, 3, 4, 5. Okay. 4, 2, 1, 2, 3, 4, 1.